All right, let's take a look at lesson 8.3, trigonometry. Now, before we start this lesson, one thing you need to make sure that you have is a scientific calculator that has sine, cosine, and tangent. You need to make sure it can do inverse cosine, which is the sine -1, cosine -1, and tangent -1. And the last thing, make sure your calculator is in degree mode. Now, if you have trouble figuring that out, you can always bring it to me in class and we can take a look at it and I'll show you how to use it. So, trigonometry. This is what this entire chapter is about. It is the study of triangle measurements. Sometimes we're going to be looking for the length of a side of a triangle. Sometimes we're going to look for the angle inside of a triangle. And we're going to use our trigonometry to find it. Now, a ratio is the lengths of the sides of a right triangle is called the trigonometric ratio. Remember, a ratio is a fraction. So we're going to set up some of these ratios as a fraction, and remember to always put them in simplest form. Three most common trig ratios that we're going to look at is sine. Now, cosine and tangent. Now, the abbreviation for this is SIN. That's still said sine, not sin. So we have sine. This is COS for cosine, and then tangent. So these are the abbreviations we'll be using, and these are what they stand for, sine, cosine, and tangent. Now, trigonometric ratios here. These are the ratios. Sine of angle A, this is called our reference angle. It's always going to be sine, cosine, and tangent of an angle measure. So it's what we call our reference angle. The reference angle is the angle that we're looking at, or we're starting from. Here, this is angle A. So in all three of these, we have sine, cosine, and tangent of angle A. Now, we're either going to do this angle or this angle. We don't use the right angle. So we do not use sine, cosine, and tangent of a right angle. And the reason why is because the opposite side is the same thing as the hypotenuse. Now, this sine, cosine, and tangent, these trig ratios only work for a right triangle. Now, we're going to learn some other ways later in this chapter on how to use different trig functions to work with triangles that are not right triangles. But because each of these deals with a hypotenuse, that means that we're going to be dealing with a right triangle. So let's take a look here. The sine of angle A. This is the length of the side opposite of angle A, which opposite is across from. So if you were to take this angle and cut it in half, it would point right to the side opposite, which is length of A, and it's over the hypotenuse, which is across from the right angle, which is C. So we have the ratio of A to C. Cosine of an angle, angle A, is going to be the adjacent, length of the adjacent leg. The adjacent leg means next to angle A, but not the hypotenuse. Notice that C is also adjacent to angle A, but C is the hypotenuse, so it's not a leg. Remember, these two legs, these two sides here are the legs of the right triangle. They're the ones that meet at a right angle. So the adjacent leg B over the hypotenuse C. And then we have tangent of angle A. Tangent is where we get the opposite of angle A, which is the side A, and we have the adjacent of angle A, which is going to be side B. So let's take a look here at a way to help you remember this. And it's kind of a silly saying, but it helps you remember what sides to put where. So the saying is SOHCAHTOA. If you can memorize this, it'll help you when you get to the ACT, when you're on your test, and you're having to remember what the trig functions are. This little phrase here will help you memorize it. SOHCAHTOA. S, SOA, stands for sine. Now, what I use is a Greek symbol theta to represent an angle measure. This is our reference angle. It could either be this angle or this angle. So sine of the angle is equal to the opposite over the hypotenuse. So we get opposite and hypotenuse. So sine, length of the opposite over the hypotenuse. Ka is going to be the cosine of the reference angle theta is equal to the adjacent leg over the hypotenuse. And then lastly, we have the tangent. So we have cosine, adjacent, hypotenuse. Now we have tangent, which is the opposite leg over the adjacent leg. So tangent of theta, it's always tangent of the angle measure. That's going to be the opposite leg over the adjacent leg. So memorize this. This will help you set up your trig functions. All right, so let's practice and find a couple trig ratios. What are the sine, cosine, and tangent ratios for angle T? So the first thing you want to do is you want to identify your reference angle. In this case, it's angle T. So I'm going to go over here and circle angle T. So everything is going to be in reference from this. So first off, we're going to start with the sine of angle T. Now, sine, remember, is opposite over hypotenuse. So the opposite leg is going to be 8 over the hypotenuse, which is 17. Now, if this confuses you at all, the first thing you should always find is the hypotenuse. Identify the hypotenuse. If you need to put an H above it, that's fine. That helps you identify the hypotenuse. Now, the opposite leg and adjacent leg, don't mark those because those could be opposite depends on what your reference angle is. Because 8 is opposite of angle T, but 15 is opposite of angle G. So depending on your reference angle, one could be opposite and adjacent for each one. So now let's take a look at cosine. The cosine of angle T is going to be the adjacent leg over the hypotenuse. So we have adjacent, which is going to be next to it. It's like if you're standing here, you could touch it, so that's going to be 15 over 17. 15 over 17 cannot be reduced, so this becomes our ratio of the cosine of angle T. Now the last one we're looking at is the tangent of angle T. Tangent, remember, is opposite leg over adjacent leg. So if we start at angle T, the opposite would be 8, adjacent next to 15, and so it's 8 over 15. This cannot be simplified, so this becomes our trig ratio. So now let's look at another one, part B. I want you guys to find the trig ratio for sine of m, cosine of m, and tangent of m. I'll pause the video, and when you come back, check your answers. Okay, let's see how you did. See if you set these up correctly. Once again, our reference angle is m, so I circle this one. Now, the opposite side is going to be the 2 radical 3 from m. The adjacent side would be 2, and the hypotenuse for this triangle is 4. It's across from the right angle. So what I've done is I've set up your ratios, but I have not simplified it yet. So sine is going to be the opposite leg, which is 2 radical 3, over the hypotenuse, which is 4. Now this can be simplified down because the outside numbers can simplify. 2 goes into 2 once, and it goes into 4 twice, so our answer would be square root of 3 over 2. So let's look at the cosine of m. Cosine is going to be the adjacent leg over the hypotenuse. So the adjacent leg is 2, hypotenuse is 4. Reduce this down to 1/2. And the last one, tangent is going to be the opposite over the adjacent. So the opposite here is 2 radical 3. The adjacent is 2. The 2's cancel, we're leaving us with just the square root of 3. So it's very important that you understand what is the opposite leg, what is the adjacent leg to an angle, and which one is the hypotenuse. The hypotenuse doesn't change, but the opposite and adjacent can, based on which angle you're referring to. All right, so let's take a look at another problem. Okay, example 2a. Now you notice these are different in your notes because I brought these before we're going to do our application problem. So let's see how we will use this. Now, this is the part where most people start to struggle, and that's determining which trig function we're going to use. So if you look at the information, you have to see what information did they give me in the triangle. I have my right angle, and the first thing I want you to do is I want you to identify the hypotenuse, which means that 17 is our hypotenuse. It's across from the right angle. So I'm going to mark this here. Now my reference angle is 54 degrees. This angle right over here. So 54 degrees, I have this is my reference angle, so W would be my opposite leg. Even though we don't have this information, we're looking for it, so we consider that to be given information. This is going to be our opposite leg, and this is going to be our hypotenuse. So if you look, remember back, opposite and hypotenuse is using the sine function. So we're going to take sine of 54 degrees. Now, sine of 54 is equal to the opposite, which in this case is W, over 17, the hypotenuse. So what we're going to do is the easiest way to solve this is to set up a proportion. So put sine of 54 over 1, and now we have two fractions equal to each other. So next step is to cross multiply. When we do proportions, we do 1 times W, which is going to give us W, and 17 times the sine of 54. Now the way we write 17 times the sine of 54 is just putting 17 out front and then write sine of 54. It is not 17 times 54, it is 17 times the sine of 54. So we take our calculator, and now we're going to first turn it on. So my calculator allows me to put 17, then hit the sine function, 54, close my parentheses, and hit enter. Now, our directions say round to the nearest tenth, which means I look at 13.77 is in the 10th place. 5 means I'm going to round it up to 13.8. So W is equal to 13.8. So let's look at the next one. The next one here, we have 28 degrees here. Notice that we do not have our hypotenuse, which means the only trig function that does not have the hypotenuse is the tangent function. So that means we're going to be using tangent for this. So the tangent of 28 degrees is equal to the opposite. So this is 28 right here. This angle right here is 28. That's the measure between here and here. So the opposite of this is going to be the 1.0, and the adjacent is going to be the W. It's the angle that's next to it, the side that's next to it, but not the hypotenuse. So tangent of 28 is equal to 1.0 over W. Once again, we'll put it over 1, and we'll cross multiply. Now notice in this one here, the variable that we're looking for is in the denominator. We're over here is in the numerator. So we have to do an extra step for this one, because when we cross multiply, we get W tangent 28 equals 1 times 1.0. Now, we're looking for W, so we have to get rid of the tangent 28. So just like we would in algebra, you are going to divide both sides by the tangent 28. So this cancels and leaves us with W. And so now we go to our calculator. And we take 1, you don't have to put the 0.0, divided by tangent 28. Close your parentheses, and that gives us the 1.88. So we're rounding to the nearest tenth, which means this 8 is going to round this 8 up to 9. So our answer is 1.9. All right, pause the video, you work out part C, and then come back and let's see how you did. All right, so let's make sure you set it up correctly. This is our reference angle of 33 degrees. We have the hypotenuse, which means we're not using tangent. And as we look at this, I do not have my opposite leg, but I was given the adjacent leg, which is our variable W. So that means we're going to be using the cosine, adjacent over hypotenuse. So it's the cosine of our reference angle, 33 degrees, is equal to W over 4.5. Cross multiply, 1 times W is W, and 4.5 times the cosine of 33. Once again, we go back to our calculator, and we'll take 4.5 times the cosine of 33. And that gives us 3.77, which means it's going to round to become W is equal to 3.8. All right, so if any time you got lost or confused, rewind it, go back and watch how we work these. And now let's go on to example 3, or part B of this. Just kidding. All right, so now we have a word problem. In 1990, the Leaning Tower of Pisa was closed due to a safety concern. The tower reopened in 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful as a result of tilt to 5 degrees reduced from 5.5. Suppose someone drops an object from the tower at the height of 150 feet and the object lands down here in the ground straight below it. How far from the base of the tower would this object land? Round to the nearest foot. So they give us what we're rounding to here. So let's take it and set up our triangle here. I know we have a triangle, but it's probably easiest if we draw another one here so we can see what we're doing. So I'm going to draw my right triangle here. And let's go back and label it. So my reference angle is 5 degrees. Tells us we moved it from 5 degrees. We have 50 feet high, and we're looking for x. How far is this from the base of the tower? So now we have to decide which trig function we're going to use. We have our reference angle. This is our right angle. So we look to see I do not have my hypotenuse, so that means I'm going to be using tangent. So we take the tangent of 5 degrees is equal to the opposite, which in this case is x. Opposite of 5 is the side of x. The adjacent leg is going to be the one next to it, which is 150. And now we put it over 1 to set up our proportion and cross multiply. 1 times x is x, and now we have 150 times the tangent of 5 degrees. So we go back to our calculator, and we will take 150 tangent 5 degrees, and we get 13.1. So rounding to the nearest foot is going to be about 13 feet. So x is approximately 13 feet. All right, let's take a look at the next one. Example 2C. Section of Filbert Street in San Francisco rises at the angle of about 17 degrees. If you walk up 150 feet up this section, what is your vertical rise? Round to the nearest foot. Set up your problem, try to work it out, pause the video, and come back and we'll see how you did. All right, let's see how we did. First of all, we need to make sure we set it up correctly. 17 is our reference angle. This is what your right triangle should look like if you did a cutout section of this street looking sideways. We're looking for the vertical rise. Vertical's up and down, so that means we are looking for this distance here. If you're going to walk up this street, you're going to walk up the slanted slope here. So this means that this is our 150 feet, which means we've been given the hypotenuse. Now, so that means we have the hypotenuse and we have the opposite leg. So we're going to be using the sine function. So sine of 17 degrees is equal to the opposite x over 150. Cross multiply. X is equal to 150 times the sine of 17. So we'll get our calculator out. Now we'll take our numbers. We'll take 150 times the sine of 17, and that gives us 43.8, and to the nearest foot gives us about 44 feet. So our vertical rise is approximately 44 feet. All right, this concludes part 1. In part 2, we're going to look at finding missing angle measures.